In this section, we're going to go over how to do a mass to mole conversion or a mole to mass conversion in terms of stoichiometry. As we've talked about before, the only thing new in stoichiometry is essentially what's called this mole to mole ratio. And I like to call these mole to mole ratios the heart of the problem, because this is the only new step that we're adding in the math. This chapter is this conversion between moles of one substance and moles of another substance. This is going to be present in every single stoichiometry problem. So with this, we're going to be going from grams to moles to a substance, or moles of a substance to grams of a substance. And from there, this mole to mole ratio is going to be central to our stoichiometry problems. The specific types of reactions that we're going to be doing in these problems today, these types of conversions, is either a mass mole conversion or a mole mass conversion. And in this conversion, if it's a mass to mole, you're going to go from grams of a substance to moles of that substance, and then switch to moles of a new substance. If it is a mole mass problem, you're going to start with moles of a substance, switch using the mole to mole ratio to moles of a new substance, and finish with grams of that second substance. So all we've been doing here is adding on one step to the mole to mole ratio that we started in our previous lesson. Which one of these that we use is dependent on what we are asked in the initial question. So looking at this sample number 4, how many moles of aluminum will react with 4.8 grams of manganese 2 oxide? So I am starting with 4.8 grams of the manganese 2 oxide, and I'm looking for moles of aluminum. So this is the type of problem that is a mass mole problem, because I'm starting with the mass of a substance and I'm going to be converting to moles of that substance. I'm going to switch to a little bit finer point of a pen because it's a little bold right there. So I'm going to be starting with the grams of that substance. 4.8 grams of manganese 2 oxide. Okay. The first step is going to be drag my units down so that I can cancel out those grams of the manganese 2 oxide. And the next step is I'm going to go from grams to moles. So moles of manganese 2 oxide is going to go into the numerator. I'll put the numbers in here in just a minute, but the next step, I'm going to drag my units down, moles of manganese 2 oxide in the denominator. Now this is the first time that moles are in the denominator, and in the last class I mentioned that the first time that moles go in the denominator, you're going to put moles in the numerator and use the mole to mole ratio. The moles that go in the numerator are going to be the moles that you're solving for, and in this question we are solving for aluminum. So moles of aluminum will go into the numerator. So this part right here, this mole over mole, is our mole to mole ratio. So that is the new piece to this problem. So to solve this problem, I need the relationship between grams and moles of manganese 2 oxide. So I need the molar mass. The molar mass is the number of grams for every 1 mole of a substance. So the mass of manganese is 54.94. The mass of 1 oxygen is 16.00. So the molar mass of manganese 2 oxide is 70.94 grams for every mole. The step that we worked on last time was this mole to mole ratio. Anytime you see the fraction with 2 moles in it, you are going to use the coefficients from the balanced equation. the coefficient on the aluminum is 2, and the coefficient on the manganese 2 oxide is 3. So by substituting in the coefficients, now you're ready to solve for this problem. 70.94 is going to be an exact number. I will not factor that into my sig figs. The 2 and 3 are also exact numbers. They have infinite sig figs. So where I look for my sig figs on my answers is going to be this number I'm given in the question, this 4.8. So when I put this in my calculator, I get 0.045109 with a little bit of rounding. I'm going to round my answer to 2 sig figs. Leading zeros are not significant, so my first significant digit is 4. The second significant digit is 5, and that is my final answer. To get my units, I'm going to cancel out and see what's left over. So grams of manganese 2 oxide reduces with the denominator. Moles of manganese 2 oxide reduces. So I'm left on my final answer with moles of aluminum. Let's try another question using the same balanced equation, but this time let's do a mole mass question. This time we're going to start with moles and end with grams. We are starting with 8.4 moles of aluminum and determining the number of grams of aluminum oxide produced. So this is a mole mass question because you're starting with moles and you're solving for mass. So I'm starting with 8.4 moles of aluminum. The first step, I'm going to cancel those moles of aluminum by taking them down into the denominator. And again, this is the first time the moles are in the denominator, so that means I'm going to do the mole to mole ratio first. So the substance I'm switching to is the moles of aluminum oxide. The next step, drag my units down, moles of aluminum oxide. Now, I do have moles in the denominator, but I've already done the mole to mole ratio. What I need to put in the numerator is what I'm solving for, and that is grams. So this last step here will have the molar mass of the aluminum oxide. To go back and get the numbers, I've got my mole to mole ratio here, or the heart of the problem. That number comes from the coefficients from the balanced equation. So in the balanced equation, there is 1 mole of aluminum oxide for 2 moles of aluminum. For the aluminum oxide, we need to double the 26.98 for aluminum and add to it 3 oxygens at 16 to get its molar mass, which is 101.96 grams for every 1 mole. We are ready to solve the problem. My answer is 428.232. Rounding it to sig figs, I started off with just 2 sig figs, so this answer is going to round to 430. Now the reason why this doesn't round to 43 is because numerically 43 is not close to 430. We need to make this number have a placeholder 0. So by just placing a 0 behind it with no decimal, this 0 is not significant. So there's only 2 sig figs here, but yet the number is closer to the actual value of the answer than 43. So that is the reason why we need to put the 0 there. find my units by canceling my terms. So moles of aluminum cancel, moles of aluminum oxide cancel, grams of aluminum oxide are my final unit and answer, and I'm all done. Now, there are 3 additional practice problems down here. What I think would be a good idea, and this is up to you all, is I think it would be a good idea for you to have this video paused and take a few minutes to solve these 3 problems. And then see the problems worked out so that you can check your answers. If you as a class don't feel that you are ready to see that yet and you need to see more worked through, then let the video continue to play. But at this time, it's a good time to kind of see what do you know on your own first, and then check your answers. All right, welcome back. We're going to go through the photosynthesis reaction. I'm going to go a little bit quicker pace just because I've gone through the 2 examples in detail. So now I can kind of go through and show the setups here so you have something to compare to. So what mass in grams of glucose is produced when 3 moles of water react with excess carbon dioxide? So I'm starting with 3 moles of water. This is going to be a mole mass question. First step, pull those moles down into the denominator. This means that I'm going to do the mole-to-mole ratio here because it's the first time the moles appear in the denominator. Glucose is going to go into the numerator. To cancel those glucose, moles of glucose in the denominator, going to grams of glucose in the numerator. The numbers for the mole-to-mole ratio, and you know it's the mole-to-mole ratio because it's the fraction mole divided by mole, come from the balanced equation. The coefficient for glucose is 1. The coefficient for water is 6. The next step is grams to moles. This is the molar mass. So the number of grams from the periodic table is equal to 1 mole. The molar mass of glucose is 180.18 grams. When I solve this problem, I will round my answer to 3 significant figures. Rounding my answer to 3 significant figures, I get 90.1, and after my units cancel, I have grams of glucose. Looking at the last problem, how many moles of nitrogen monoxide are formed from the reaction of 824 grams of ammonia? I'm starting with 824 grams of ammonia, which is NH3. This is going to be a mass mole question. Drag my grams to the denominator so that they cancel. I can't do the mole-to-mole ratio yet because I haven't canceled these grams. So from grams, I need to switch to moles using the molar mass. Now to cancel out those moles of ammonia, I can drag it to the denominator. So here is the first time that I'm seeing moles in the denominator. So that means moles are going to go into the numerator. What I'm solving for is moles of NO, and I'm ready to put my numbers in. Grams to moles, this is going to be the molar mass. Adding up the molar mass of ammonia, the number goes with the grams. 17.04 grams is what you should be adding up. for every 1 mole. And in the mole-to-mole ratio, the coefficient of nitrogen monoxide is 4. The coefficient of ammonia is 4. So my final answer, rounded to 3 sig figs, is 48.4 moles of nitrogen monoxide. The last question is going to start off very similar to letter A. And the reason why is because you're starting with the same amount of grams of ammonia. 824 grams of ammonia, but this time we're going to convert to water and not nitrogen monoxide. So grams of ammonia need to be canceled first before we go to moles. We cancel those with the molar mass. So we're going to put grams in the denominator, moles in the numerator for ammonia. Drag those moles of ammonia down to the denominator. Now I can do my mole-to-mole ratio. Moles of water are going to now go into the numerator. From the previous question, 17.04 grams make 1 mole. That's the molar mass of the ammonia. From the balanced equation, there are 6 moles, because that's the coefficient of water, for every 4 moles of ammonia. So the number of moles of water, rounded to 3 sig figs, is 72.5 moles of water. Hopefully this gets you enough practice and enough kind of exposure to the mass mole and mole mass problems. You will have 3 problems with your homework assignment to work on, and we'll go over those problems in class tomorrow.